Welcome to part 4 of Unit 1.8 Acids, Bases and Salts topic. We're going to be starting on page 17. We're now moving on to the second specific type of reaction of acids, and that's the reaction of acids with bases. And we've met this before earlier in this topic, but you should also remember this from your Year 8 study of chemistry. When an acid reacts with a base, it produces a salt and water. So remember, all of our acid reactions produce salt, but our side product this time, instead of being hydrogen, as with the acid and metal reactions, the side product is water. Now we need to think about what a base is, and we learned by definition a base is a metal oxide or a metal hydroxide. We learned that earlier on in the topic. And we learned that when a base reacts with an acid, it produces a salt and water only. And that's an example of a neutralization reaction, when an acid reacts with a base. So you can see I've got two general equations, but they end exactly the same. We're just looking at the two different types of bases, metal oxides and metal hydroxides. They both react with acids to give us a salt and water as our side product. How we name that salt is exactly the same way as before. We take the first part of the name from the metal, second part of the name from the acid, but it changes its ending. So you can see here I've got the reaction of sodium hydroxide and hydrochloric acid. So if I am naming my salt, the first part of the name comes from the metal. I ignore the hydroxide part. So you can see the first part of the name is sodium. And the second part of the name comes from the acid. And remember, the acid changes its ending. Hydrochloric acid changes to chloride. So we're going to have a look at the reaction of copper oxide and sulfuric acid as an example of these reactions of acids and bases. So this is a reaction between copper oxide and sulfuric acid, an example of a metal oxide reacting with acid. So we'll pour the sulfuric acid into the boiling tube first of all. And you can see that your acid is a colourless solution. And then we'll add in our copper oxide. Copper oxide, you should be familiar with the colour, but just to see it, you may not have seen it before, it's a black powder. So I'm going to put it into my sulfuric acid. And if you think of the products of this type of reaction, we should be getting a salt and water. Neither of those are a gas, so you can see we've got no bubbling in this case. You can see not very much is happening, and copper compounds are quite unreactive. So what we're going to do is put it in a hot water bath. So I've got my kettle boiled here. I'll fill my beaker with some hot water, and we'll place the boiling tube in the beaker. This takes a few minutes to react, so we're just going to leave it and have a look at how it reacts later. So as I said, this reaction takes quite a while. So we took this video as a time lapse. We videoed it over about 10 minutes, but we've shortened it down to just 15 seconds. So you can see the reaction is happening really quickly here. And there we're back to the start again. So you can see as the copper oxide reacts with the sulfuric acid, the solution of the acid changes from colourless to blue. And eventually all the black solid would disappear, but we've added an excess of it. And so some will still remain at the bottom. So the video is just looping round, and as I say, this happened over about 10 minutes or so, but we've shortened it down, quickened the video up so that it only lasts about 15 seconds. So again, you can see as the copper oxide is reacting, you're producing a blue solution. So you can see at the end of this reaction, our colourless solution of acid has changed to a blue solution, and that's because we have formed copper sulfate from the reaction of copper oxide and sulfuric acid. You can see that some of my black solid has disappeared into the solution, but we're still left with an excess at the bottom, showing that this solution is saturated, no more can react with it. But over time, you can see that the colourless solution has changed to blue, and that's your main observation here. So let's fill in those observations on page 17. You can see the box is smaller, and that's because we don't have as many observations here. So the main observation is that the colourless solution of your acid, colourless solution changes to blue. We don't have fizzing in this reaction because we're not producing a gas, we're only producing a salt and water. We have no heat release because if you remember back to your general observations, this is one of the exceptions. When copper oxide reacts with acid, it does not release heat. But what we do see happening is that our black solid disappears. So if you can try and squeeze that in as well, or write it underneath. Black solid disappears. We added an excess, that's why some sat at the bottom, but the black solid will react with your acid and eventually disappear. What are our products? Go up to your general equation and you can see that we get a salt and water in these reactions. The salt we name from the metal oxide, and the second part of the name we name from our acid. So the metal within our metal oxide is copper. So the first part of our name is copper. Second part of the name comes from the acid. Sulfuric changes to sulfate. So it's copper sulfate plus water. Let's now write our word equation for that reaction. So we've got copper oxide plus sulfuric acid reacts to give us our copper sulfate, which we've just named above. Copper from our copper oxide, sulfate from our sulfuric acid, and our side product this time is water. Let's try the balanced symbol equation for that. Copper oxide, this time I need to do my swap and drop with it. And again, it might be given to use copper 2 oxide, but if not, look at the back of the periodic table and you can see that copper appears as Cu with a charge of 2+, which means it has a valency of 2. Oxide is just oxygen, so it's O, and again oxygen is group 6, so it has a valency of 2 as well. I can cancel that down to a ratio of 1 to 1, and then when I swap and drop I simply get CuO. So CuO plus sulfuric acid, again you need to be familiar with your formula, you should know it by now, is H2SO4. Copper sulfate is my salt, and again I need to do swap and drop. Copper has a valency of 2. Sulfate, you should be familiar with this by now, but it's SO4 with a charge of 2-. So I write down my SO4 first of all, and then I use the 2 for my valency. That can cancel down to 1 to 1. And then when I swap and drop, I end up with CuSO4. And then plus water is plus H2O. You could make your list, but if you have a quick look, your equation is balanced. You can see essentially that your copper has replaced your hydrogens, and then the hydrogens have jumped in with the oxygen to form water. So that equation is balanced. If you wanted to check, you could make your list and count up your atoms. Okay, we mentioned this in the previous page, but because we've got an acid reacting with a base, in the last example it was copper oxide, so it was an example of a metal oxide. It's reacting with an acid to form a salt and water only. Our salt was copper sulfate and our other product was water, and we didn't have any other products. And that's a definition of neutralization, when an acid reacts with a base to produce a salt and water only. We had our acid was sulfuric acid in the last example. Our base, or our metal oxide, was copper oxide. And we produced a salt, which was copper sulfate. And our only other product was water. So this is the definition of neutralization. And all of the following examples are also neutralization equations. You should try and write the equations for them yourself, and then I will go through the examples to check that you're doing them correctly. But you should try them yourself because you need to be able to do these yourself. Always start with your word equation, then work out your balanced symbol equation from that. So pause the video if you feel able to give these a go yourself. If not, try one example with me and then try the rest yourselves. So the first one we have is sulfuric acid and sodium hydroxide. So the first thing I need to do is write my word equation. So I've got sodium hydroxide first of all. Reacting with sulfuric acid. So those are my reactants, the things I'm reacting together. So they go on the left hand side. Again, try and write small so that this can all fit on one line. Think again of your general equation. You've got a metal oxide or hydroxide reacting with an acid to produce a salt and water. What's the name of our salt going to be? Well, the first part of the name comes from the metal, which is sodium. Second part of the name comes from the acid. Sulfuric acid changes to sulfate. What's our other product? Not hydrogen this time, but water. A salt and water are our products. Okay, swap and drop now to get our formula. And we need to do that right from sodium hydroxide. So, sodium is Na. Hydroxide appears in the back of your periodic table as OH minus. Remember, when I'm using molecular ions, that's ions that contain more than one atom, I write down the formula first, which is OH. And then I use the charge for my valency. My charge is minus, so my valency is 1. Sodium is in group 1, so it also has a valency of 1. Ratio is just 1 to 1. Can't simplify that down, so I can just swap and drop. And I will ignore those ones. So sodium hydroxide is just NaOH. Sulfuric acid then, you should know by now, is H2SO4. Leave a bit of room for your balancing numbers in case we need to balance it. Sodium sulfate then, we'll do our swap and drop again. Sodium is Na in group 1, so it has a valency of 1. Sulfate, hopefully you're familiar by now, it's SO4 with a charge of 2 minus. So we write down our SO4 first of all, and then we use the 2 minus for our valency, which is just 2. Swap and drop that then. I'm swapping 1 down to my sulfate, so I don't need brackets around it because I'm going to end up ignoring that 1 anyway. But I do include the 2 after my sodium, so it's Na2SO4 plus my water, which is H2O. My equation is not balanced this time, so I must make a list in order to balance it correctly. So make a list of all your elements, being careful that you separate them all out and that you list them all. So we've got sodium first of all, which is Na. Then we've got oxygen. Then we've got hydrogen. Hydrogen we've already included. And then we've got sulfur. Let's copy that list on the other side in the same order. Sodium, oxygen, hydrogen, sulfur. Okay, time to count up on either side. We've got 1 sodium. Count your oxygens carefully. We have 1 here in sodium hydroxide, but then 4 here in sulfuric acid. So that's a total of 5. How many hydrogens do we have? Well, we have 1 in sodium hydroxide and 2 in sulfuric acid. So that's a total of 3. And then you have 1 sulfur in sulfuric acid. Over on the right hand side now, we have 2 sodium atoms. We have, again, 4 plus 1 is 5 oxygens. We have just 2 hydrogens. And we have 1 sulfur. So you can see that my oxygens are balanced, my sulfurs are balanced, but my sodiums and hydrogens aren't. Probably the easiest thing to do is fix your sodium first of all. And again, if you need to draw your boxes in front of this formula, you can, to remind you that when we're balancing, we can only put numbers in these boxes. So I need 2 sodiums on the left, and so I put a 2 in the first box. I need to update my list to see what that's changed. So I now have 2 sodiums. Be careful with your oxygens and hydrogens, because I now have, and follow along where I'm drawing, I have 2 times my 1 oxygen, which is 2 in sodium hydroxide now. But I've still got 4 here. So that's 2 plus 4 is 6 oxygens. Be careful also with your hydrogens. So again, I have 2 times by 1 hydrogen in sodium hydroxide, that's 2. Plus 2 in my sulfuric acid, and 2 plus 2 is 4. Okay, so I fixed my sodiums, but my oxygens and my hydrogens still aren't balanced. How do I get more of those on the right hand side? Well, I put a 2 in front of the water. Think what that affects now. In terms of my hydrogens, I've got 2 times 2, which is 4. And in terms of my oxygens, I've got 4 in sodium sulfate, and then 2 times 1 in the water. That's a total of 6. So you can now see my equation is balanced. So if we were to rewrite that, it would be 2 NaOH plus H2SO4, giving you Na2SO4 plus 2 H2O. The next example is magnesium oxide and hydrochloric acid. And you should give this a go before checking your answer is correct. So if you haven't already done so, pause this video, give it a go, and then you can check your answer is correct. So let's write our word equation first of all. We always need to do that so we can know what our products are. So we've got magnesium oxide reacting with hydrochloric acid. Remember, back to your general equation, we're going to get a salt and water. Our salt is going to be magnesium. That's the first part of the name. Second part of the name comes from your acid. It's going to be chloride this time because hydrochloric acid changes its name to chloride. Plus water. I'm just about to squeeze that in. Okay, magnesium oxide, I'm going to need to do swap and drop. Magnesium is Mg, oxide is just O. Magnesium's in group 2, so it has a valency of 2. Oxygen is in group 6, so it has a valency of 2. That can cancel down to Mg1 and O1. Swap and drop that, you just get MgO. Plus your hydrochloric acid, which is HCl. Magnesium chloride, need to do swap and drop, but it's just a simple swap and drop with our chloride salts. So magnesium is Mg, chloride is just Cl. Magnesium is in group 2, so has a valency of 2. Chlorine is in group 7, so has a valency of 1. So when I swap and drop that, I get Mg. I was swapping 1 down from my chlorine, so I don't need to include that. So it's just Cl and then 2 down from my magnesium. Plus your water is H2O. Okay, we need to balance this now. So make a list of your elements. You've got magnesium, oxygen, hydrogen and chlorine. And we copy that list on the other side as well. Magnesium, oxygen, hydrogen and chlorine. Count them up on either side. You have 1 magnesium on the left, 1 oxygen, 1 hydrogen and 1 chlorine. On the right you have 1 magnesium, 1 oxygen, 2 hydrogens and 2 chlorines. Remember, we can only balance by putting big numbers in front. I need 2 hydrogens and 2 chlorines on the left, so that's very easy to fix. I can just put a 2 in front of my HCl. Let's change my list. I've now got 2 hydrogens on the left and 2 chlorines, and you can see my equation is balanced. One more example of this type on page 19. And again, you should give this a go before watching the video as to how to do that. You can use the video to help you if you're stuck, but do try and do it yourself. Okay, so this time we have calcium hydroxide reacting with nitric acid. Think of your general equation again. We're going to get a salt and we're going to get water. Our salt this time is going to be calcium nitrate. And our side product is water. Okay, let's try and get our formula now. So calcium hydroxide calcium is Ca. Hydroxide, remember, is OH minus. So we write down OH and our minus sign gives us our valency of 1. You can check the back of the periodic table for that. Calcium is in group 2, so it has a valency of 2. Because I'm swapping down a 2 to my hydroxide, I'm going to need to put brackets around my molecular ion so that that 2 applies to both the oxygen and the hydrogen. So if we swap and drop those, I'm going to get Ca brackets OH and then my 2 goes outside. If you hadn't included the included the brackets, you would have ended up with CaOH2. That would mean only one oxygen and two hydrogens, so that is not correct. Nitric acid, you should know the formula by now, is HNO3. That gives us calcium nitrate. Calcium is Ca. Nitrate, again, you should know by now, but check your back of your periodic table if you're stuck. Nitrate is NO3 with a charge of minus. So first thing I write down is everything apart from the charge, including the little 3 at the bottom, so NO3. I'm going to put that in brackets because it's a molecular ion. How I get the valency of it is I look at the charge. It's minus, so that means it has a valency of 1. Calcium is in group 2, so it has a valency of 2. Can't cancel that down at all, so when I swap and drop, again you can see why we needed brackets, because we end up with a formula of Ca, don't need to include my 1, and then NO3 in brackets, and then outside the brackets I put a 2 that was swapped down from my calcium. Your other product is water, which is H2O. If you've got to this stage, try and balance it now. Write your list of elements, count up your elements, and see if you can balance it. Okay, so having a check through that, you make a list of your elements. It's Ca, O, H, and nitrogen, N. Make that list on the other side: calcium, oxygen, hydrogen, nitrogen. Let's count them up. I have 1 calcium on the left. Oxygens, be careful with. I have 2 within my calcium hydroxide because that little 2 outside the brackets multiplies everything inside the brackets. I have 2 plus 3 in my nitric acid, so that's a total of 5. Moving on to the hydrogens then, again be careful, you've 1 inside the brackets, but that's multiplied by 2, so that's 2 in your calcium hydroxide and 1 in your nitric acid, so that's a total of 3, and then I've just 1 nitrogen. Over on the right hand side then, calcium is just 1 because it's not inside the bracket, so the little green 2 does not apply to it. Oxygens you need to be really careful with. Remember that 2 multiplies everything inside the bracket by 2. So I have 3 inside the brackets, but times by 2 is a total of 6. And then I have 1 in my water as well. So that gives me a grand total of 7 oxygens. Hydrogens, I just have 2 in my water. And nitrogens, again, there's 1 inside the bracket, but I have 2, that's multiplied by 2. So I have 2 nitrogens. Now is a good time to draw your boxes in front of your formula, because this looks quite complicated to balance. We'll find it's not too bad, but we need to put boxes to remind us that we can only put numbers in front of the whole formula. So when you're at this stage and you've got quite complicated numbers, the best thing to do is look for ones which are easy multiples of each other. So for example, on the left we have 1 nitrogen, and on the right we have 2. So I just need to multiply the number of nitrogens on the left by 2. And I do that by putting a 2 in front of the nitric acid. I need to change my list for what that affects. So you can see the first thing it affects is hydrogen. So I've now got 2 times by 1 hydrogen in nitric acid plus the 2 from calcium hydroxide. So I've got 4 hydrogens in total. It also affects my nitrogen, which is the thing I'm trying to fix. So I've got 2 times by 1 nitrogen, which is now 2 nitrogens. Oxygens I need to be careful with as well. I've now got 2 times 3 oxygens, which is 6, but plus the 2 from my calcium hydroxide is a total of 8 oxygens. Okay, and now I'll maybe move to my hydrogens, again because they are easy multiples of each other. You've got 4 on the left and only 2 on the right, so I need twice as many on the right. So I put 2 in the box in front of the water. So I've now got 2 times my 2 hydrogen, which is 4. But I've also affected the oxygen. So I've now got 2 times my 1 in water, which is 2, plus the 6 from my calcium nitrate. 6 plus 2 is 8. And you can see my equation is now balanced. So it may look scary at the start, but you need to just persevere with it. So it's calcium hydroxide, Ca brackets, OH2, plus my 2 nitric acids, reacting to give me calcium nitrate, Ca brackets NO3, 2, plus 2 waters, 2H2. That's just at the end of your reaction of acids with bases. Once you've that all filled out, you can either take a break or move on to part 5, which looks at the reaction of acids with metal carbonates and hydrogen carbonates.